Good morning, students. Today we will discuss about sequences and series. Sequence and series. Listen. So, sequence and series. Sequence and series. Yes, this is also a very significant chapter in mains, advanced, and other competitive examinations. It has a nice weightage. So let us first of all let us define sequence. What is a sequence? See Nana. Yes, what is a sequence? Very simple. A list of numbers. A list of numbers formed according to some definite rule. Some definite rule is called a sequence. Is called a sequence. Very simple. What is a sequence? It is a list of numbers. List of numbers formed according to some definite rule. This list is called a sequence. Yes. About this sequence, always a sequence is a function. What is a sequence? A sequence is a function whose domain is always the set of natural numbers. So what is a sequence? A sequence is a list of numbers formed according to some definite rule. And this sequence is always a function whose domain is set of natural numbers. If you denote a sequence as a function, yes, sequence is a function whose domain is always n. Domain of a sequence is a function whose domain is n. If the range of this sequence is r, then the sequence is called a real sequence. In this case, this sequence is called a real sequence. Whenever its range is r or subset of r, then the sequence is called a real sequence. So we will see some examples of sequences. Yes, for example, I will take a list of numbers 1, 4, 7, 11, dash dash, 19, etc. What is this? It is a sequence. So another example, 2, minus 4, 8, minus 6, etc. dash dash up to infinity. I shall also take one more example, 2, 3, 5, 7, 11, etc. up to infinity. So these are some examples of sequences. If you take first sequence, there is first term is 1 and the last term is 19. That means this sequence containing finite number of terms, therefore the sequence is a finite sequence. And what about these two? They are also a list of numbers containing infinite number of terms, therefore they are known as infinite sequence. If the number of terms is finite, then the sequence is a finite sequence. If the number of terms is infinity, then it is an infinite sequence. So sequence is what? Sequence is a list of numbers formed according to some rule, any rule. So these are the sequences. Examples. Sequence is always a function whose domain is always set of natural numbers n. Whenever its range is R, that sequence is called a real sequence. After sequence, we will see what is a series. See Nana, series. What is a series? A series is obtained. A series is obtained. A series is obtained by adding or subtracting. Adding or subtracting the terms of a sequence. Terms of a sequence. Very simple. What is a series? What is a series? Series is obtained by adding or subtracting the terms of a sequence. For example, if a1, a2, a3 dash dash an, if this is a sequence, this implies if you add or subtract the elements a1 plus a2 plus a3 plus a4 dash dash an, what is this? This will be a series. That's all. What is a series? A series is obtained by adding or subtracting the terms, the elements of a sequence. If this is a sequence, this is list of numbers is a sequence, then what about this a1 plus a2 plus a3 plus dash dash up to an? This is called a series. Next we will see progression. What is a progression? There is a difference between series and progression. What is a progression? Progression, if in a sequence, if all the terms are formed or follow certain pattern, then it is called a progression. See, if the terms of a sequence follow certain pattern, then it is called a progression. Then it is called a progression. Yes, what is a progression? Progression is also a sequence. If all the terms of a sequence follow certain pattern, certain condition, then that sequence is called a progression. There are mainly three common progressions. What the common progressions? First one is arithmetic. Arithmetic progression. First one is arithmetic progression. Second one is geometric. Progression. And the third one is harmonic progression. These are the common progressions. Arithmetic progression is simply denoted by AP. Geometric progression we denote it by GP, and harmonic progression by HP. There are some other progressions, but common progressions are these three: arithmetic progression, geometric progression, and harmonic progression. Now we will see about one by one in order. Now we will see about arithmetic progression. See now, arithmetic progression simply denoted by AP. What is an AP? A sequence whose terms increase or decrease by a fixed number is called an arithmetic progression, that is called an AP. What is arithmetic progression AP? A sequence. It is a sequence whose terms increase or decrease by a fixed number. That sequence is called an arithmetic sequence, simply denoted by AP. Generally, we will denote AP like this. If you take a term A, say this is the first term. So for upcoming terms, further terms, they will be either increase or decrease by a fixed number. For example, if A is first term, A plus D, increasing by D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, etc. In between some A plus ND, etc. What is this? This is an AP. This is an AP, arithmetic progression. We take this as general form of an arithmetic progression. Here this A is called first term. What is A? A is called first term of the AP. And what about this D? The fixed number. The constant number D is called common difference. This is called common difference of the AP. So A is first term and D is common difference. So this is the definition of AP. Now we will see. If you want to write a general term, what is general term? General term is an expression which will give us all the terms for different values of n. So these are the terms, generally terms denoted by T1, T2, T3, etc. T1 means first term, T2 second term, T3 third term, Tn nth term, etc. So in an AP, what is nth term of this AP? Whose first term is A, common difference is D. Its nth term is A plus n minus 1 into D. This is nth term of an AP series having A as first term and D as common difference. Yes, terms, nth term is denoted by Tn. Similarly, sum of the terms, sum of first n terms, Sn, capital Sn. If you take S2, what is that? First two terms, sum of first two terms. S4 is sum of first four terms, etc. If you know the sums, then also you can find the general term. Tn can be Sn minus Sn minus 1. When you know the sums of particular terms, then also you can find the nth term Tn. This is Tn. Next number, see now. Next number 3. If you want to find sum of n terms, sum of first n terms of an AP, this is given by n by 2 into 2a plus n minus 1 into d. This will give us sum of first n terms of an AP. In this also n is number of terms and A is first term, D is common difference again. Similarly, next number 4. This Sn can be also calculated like this, which is n by 2 into A plus L, A plus L, where A is first term, and L is last term. Last term means, what is last term? Here we have written Sn, that means sum of first n terms of an AP. Since it is sum of first n terms of an AP, last term will be nth term. When first term, last term are known, then sum can be found using this also. This is applicable when you know first term and last term. This is applicable when you know first term and common difference. Yes. Also, how to find common difference D? It is of course simple. What is common difference? Difference between any two terms. T3 minus T2 will give us D. T2 minus T1 will give us T. In generally, this can be written as Tn minus 1. So this will give us common difference. Yes, this is AP definition. This is an AP. General form of an AP is this. A is first term, always D is constant difference. These are some concepts. How to find nth term? This is nth term, this is also nth term. Sum of n terms, this is sum of n terms. You can use this or this accordingly. This should be used when you know first term and also last term. If you want to find common difference D, subtract any two terms, that is Tn minus 1. So in GP series also we write Sn, sum of n terms. There we also write S infinity. That is infinite, sum of infinite terms of a GP. In AP series, if you write sum of infinite terms, that means what is the number of terms? Number of terms is infinity. That means n will tends to infinity. If n tends to infinity, if you write infinity here, infinity by something infinity into a finite number also infinity. So therefore in AP, S infinity will not exist. You cannot find sum of infinite terms of an AP. Yes. Okay. Next we will see some of the properties of AP. Yes. Now we will see some properties of AP. Listen. Number 1. If three numbers A, B, C are in AP, if these three are in AP, then we can take this as 2b equal to A plus C. 2b equal to A plus C. How did you get this? Since these are in AP, common difference will be same. That is B minus A equal to C minus B. Writing B here, it becomes plus A plus C. 2b equal to A plus C, or B is equal to A plus C by 2. So this is a property of AP series. Next one, next number 2. See, if some numbers are in AP, if A1, A2, A3 dash dash AN are in AP, this implies if these numbers are in AP, if you add or subtract any non-zero number to all the terms of this AP, still the resulting series will be in AP only. What it implies? This implies A1 plus or minus K, A2 plus or minus K, A3 plus or minus K, etc. AN plus or minus K also form an AP. This also form an AP. That is, if an AP series is given, if you require, you can add same number to all the terms of AP. Still the resulting series will be in AP only. Next, take number 3. Similarly, if you have an AP, A1, A2, A3 dash dash AN is an AP series, this implies, similarly you can multiply all the terms by a non-zero number. That is, I am multiplying by non-zero number K, KA2, KA3, etc. KAN. So if you multiply all the terms of an AP, again you will be getting a new series which also form an AP. Also form an AP. These are also in AP series only. Next, number 4. Again, if you take an AP A1, A2 dash dash AN, if this is an AP, then this implies, if you divide all the terms of an AP by a non-zero number, then also the resulting series will be in AP only. That is, A1 divided by K, comma A2 divided by K, etc. AN divided by K, also an AP. This also, for these numbers also form an AP. These also form an AP series. Yes. Next, property number 5. See now. Property number 5. If A1, A2, A3 dash dash AN, this is an AP. This is an AP, and there is another AP, B1, B2, B3 dash dash BN is also an AP. It is also an AP. These are two different APs. Then this implies, number 1, if you take their sum, A1 plus B1, adding corresponding terms, AN plus BN, this series also forms an AP. Yes, what this property says, if you have two different APs, then adding their corresponding terms, you will get a resulting series. That series also forms an AP series. Next, similarly, number 2, for the two different APs, their difference, that is, subtract difference of their corresponding terms, AN minus BN, also forms an AP. This series also forms an AP. Yes. Similarly, next, number 3. If you take the product of corresponding terms, that is A1 B1, comma A2 B2, A3 B3, etc. AN BN, this series also forms an AP. It also forms an AP series. Yes. Next, number 4, in the 5th bit. These are two different AP series, then A1 by B1, A2 by B2, A3 by B3 etc. AN divided by BN. This series may not form an AP. This is important. This may not form an AP. So this point is to be remembered, this one. So by adding the corresponding terms of two AP series, the resulting series will be in AP only. By subtracting corresponding terms, then also the resulting series will give us AP only. By multiplying the corresponding terms, then also the resulting series will be giving AP series only. But if these are two different APs, then this may not form an AP. This series may not form an AP. This is to be noted. Next property number 6. See Nana, if we take a finite AP, if A1, A2, A3, A4 etc. AN minus 1 and AN is a finite AP. This is a finite arithmetic progression. Then what this implies, there is a beautiful property. Sum of first term and last term of this finite AP same as sum of second term from the beginning, second term from the ending. Similarly, A3 plus AN minus 2 etc. Those will be equal. What this property says, if you have a finite AP, then sum of first term, last term is same as sum of second term from the beginning, second term from the ending, and so on. So these values will be equal. First sum of first and last terms, sum of the terms, second from beginning and ending, and so on. This is also an important property. Next we will see property number 7. If you take an AP series, you can write nth term in terms of NO. See, the nth term, that is general term, the nth term of an AP is a linear expression, in N. That nth term is always a linear expression in N. That means nth term will be like this, AN plus B. What is this? It is a linear factor, linear expression in N. So if you find the nth term of any AP, that nth term will be in this form. Which form? Linear form. Yes. Next, number 8. The sum of first n terms of an AP is a quadratic expression in N. What does it mean? If you find the sum of first n terms of an AP Sn, then we have a formula, two formulas of course. That expression, that Sn will be always a quadratic. Quadratic means second degree expression in N, which is of the form AN square plus BN. So always Sn will be in this form. Yes. Okay. Next, property number 9. If you take an AP series, if A1, A2, A3, A4, A5 etc. is an AP series. This will give us, if you take the terms in a regular interval, for example, if these are in AP, if I take their alternate terms A1, A3, A5, etc., they will be also in AP. Any regular interval, same length of interval. Also, if you take A1, A4, A7, A11, etc., they are also in AP series. So these are some of the important properties of AP series. AP series, its definition, formulas and its properties. Yes, next we will discuss about arithmetic means. See Nana, arithmetic means, EAMs. What are arithmetic means? You can insert a single AM, arithmetic mean, between two numbers. See, what is that? A number A is called the single arithmetic mean, AM, between the two numbers small a and b, if small a comma capital A comma B are in AP. Very simple. What is a single AM? A term A is called the single AM between two numbers A comma B, if A comma capital A comma B, if these three are in AP series. In other words, you can also state this as, if three numbers are in AP, then the middle one is called arithmetic mean between A and B. Since these are in AP series, what we can write? By the property of AP, this arithmetic mean, single arithmetic mean A will be average of these two. That is, A is equal to A plus B by 2. This is single AM. Very simple. Yes, similarly, if two numbers are given, you can also insert any number of AMs, 2 AMs, 3 AMs, etc. We will see in general how to insert n AMs. See, so I shall take n numbers, n terms, A1, A2, dash dash, AN. These are called n AMs, arithmetic means, n AMs between two numbers, small a and b. These are n in number. These terms, n numbers, are called n arithmetic means between A and B if A comma this capital A1, A2, A3 dash dash AN comma B, if they form an AP, or simply if they are in AP, if these numbers form an AP, or simply these are in AP. If these numbers are in AP. Yes. So what is more than n AMs? Single AM is this. If you want to insert more AMs between two numbers, you should adopt this concept. A1, A2 dash dash AN. These are called n AMs between two numbers A and B. if these numbers in order small a comma a1 a2 a3 dash dash an comma b, if they are in AP series. If these numbers are in AP series, then these A1, A2 dash dash AN, they are called NAMs between A comma B. So this is very simple. When single AM is there, how to write it? Very simple, average of these two. But in this case, when you are inserting more than one, that is, if you are inserting more AMs between two numbers, how to find those AMs, how to find A1, A2, A3, etc. Now we will see. So, if you see this AP series, this is an AP series containing how many terms? See, A and B, they are two numbers. How many numbers are inserted between A, B? N numbers. Total, how many numbers will be there? How many terms will be there in the AP? N plus 2. That means what is B? B is N plus 2th term. That is Tn plus 2. So how to write nth term of an AP? We have seen nth term of an AP is A plus n minus 1 into D. This is the way of finding nth term. So what is B here? B is n plus 2th term. Therefore, I will use this. What is A? A is first term. If you want nth term, you should write n minus 1. Here this term is n plus 2th term. So what I should write? N plus 2 minus 1. That is n plus 1. We will suppose common difference D only. So this is B. So B is equal to this. From this I will separate this common difference. If I separate common difference, I should write A on left side first. Then this n plus 1 divides here. So this is the D for this series. So if a series is given, to write the different terms of a series, what is needed? You need first term and common difference. If you know those two, you can write any term of the series. So these are the AMs now. So now I will write the first AM. What is first AM? It is A1. But this A1 is the second term of this AP series. Second term means it is written as A plus D. In an AP series, first term is A, second term is A plus D, third term is A plus 2D, etc. So if I want A2, A2 is what? Third. This is A plus D, this is A plus 2D. If your index is 1, you are getting 1D. Index is 2, getting 2D, 3D, 4D, etc. You can write up to nth AM also. So AN will be A plus ND. So these can be found because first term is there. All the AMs are in terms of A and D only. So this is A. First term. What is D? This is D. So by using this and this, you can find all the AMs. Okay. This is what n AMs between two numbers. Single AM is simply A plus B by 2. When you are inserted more number of AMs, say n AMs, these are n AMs. They are found like this. A1 is A plus D, A2 is A plus 2D, etc. AN is A plus ND. To find these, what is required? All these n AMs are in terms of A and D. A is available first term in the series, it is available. And how to find D value? This is D. You can substitute in this and you can obtain the arithmetic mean of your choice. Okay, now these are n AMs between these two numbers now. We will see what is the sum of these n AMs. Let us see. I shall add all the AMs. Is there any particular property? What is A1? This is A plus D, A plus 2D, A plus 3D, A plus 4D, etc. Now I am adding all the n AMs. I have to add these. So they are, how many AMs are there? They are n in number. So adding n times you will get NA. Next, from the second one, all they contain D, no? I can take D common. If I D common, I have 1 plus 2 plus 3 plus 4 up to n. That is sum of first n natural numbers, n into n plus 1 divided by 2. Therefore, let us simplify. NA plus D, not D. I will take this n into n plus 1 by 2 divided into D is there, no? What is D? This is D. We will write here. D is B minus A divided by n plus 1. So I can cut n plus 1 and n plus 1. Then I will take n common from this. If I take n common, I will have A plus B minus A divided by 2. Okay. Yes, let us simplify further. If you take LCM here, LCM is what? LCM is 2. What you get? 2A plus B minus A. 2A plus B minus A. Nothing but A plus B. So what is this? This is A plus B. This is the sum of n AMs between two numbers A and B. So what is A plus B by 2? It is single arithmetic mean, single AM between same numbers. Therefore, what we can conclude now, if two numbers are given A and B, then sum of n AMs between them is equal to n times the single AM. What it is? N times of single AM. A plus B by 2 means it is single AM. Yes, this is about inserting arithmetic means between two given numbers. Yes.